Hi and welcome back to our college algebra class today. So as part of our lesson today, we are continuing with our discussion on algebra. By today, we are going to be looking out for the slope concept, which is called the gradient concept. But let's begin like this. Let's say we have this illustration. We have this line, right? Let's say here is point A, and this point we are getting what? Coordinate x1, y1. Then here too, we are getting coordinates, say B, x2, then y2. This is also coming from our Cartesian plane developed by Rene. If you have watched our first lesson on algebra, was Rene, a mathematician philosopher who came out with this Cartesian plane called the x and y. So here is the y-axis and here is what? The x-axis. And was this graph that we were able to get this line. So here is x1, y1, here it was x2, y2. The idea about the slope or the gradient concept tells us how steep or how gentle an object can move. How steep or how gentle an object can move. And we'll dive into some of these issues later on. So just stay tuned here. So if I have this slope, in gradient, we call this slope as what? A positive what? Gradient. But assuming that the slope was like this, then we'll call this what? A negative what? Gradient. So if it is this, it is called a positive gradient. That's a forward what? Slope. But if it's a backward slope, we call it what? A negative gradient. So let's take note of that. So now let's get back to the concept we want to build here. Here is x1, y1. Here is x2, y2. So it literally means that here, as the point that we're getting, since we know how to plot a point on a graph, it means that here we're getting our x1 down here as our x1 here. And we're also having our y1 also coming up here. Our y1 also here. So literally, that is the whole idea coming up here. And here too, we can also trace our y2 also from here. Then we can also trace our x2 also from what? Here, x2. So that means that we can also create a line coming up to make this. So when a vertical and horizontal line meet, they make what? A 90 degrees what? Angle. Now, follow the discussion carefully. We can clearly see that now we are having a right angle what? Triangle. Now, here is our point of origin. From the point of origin to here is x1, and from the point of origin to here is what? X2. So now, let's assume that here from here to here is 1, okay? And let's say from here to here is, let's say, 6. Now, if I want to find from this point to this point, what do you think is supposed to be? That means I'm going to subtract from here to here from the whole of origin to what? This point, 6. So it's going to what? 6 minus 1. Good. Then literally, this is also going to be for the y part too. If we have from the origin here to the y1, here say 1, and from the origin here to y2 say what? 6. That means for me to get from y1 to y2, I need to subtract 6 minus 1. Whatever I will get will be the change between the two. Okay, so if that is the case, then it means that for me to get the whole of this what? Length here, which is equivalent to this, I will have to subtract what? Y1 from what? Y2. So I'll have in here y2 minus y1, which is going to give me equivalent length from here, right, to what? This point. And when it comes to the x2, the same issue happened here. If I want to get from x1 to x2, I'll have to subtract from the origin to the x1 from the origin to what? The x2. So it becomes what? X2 minus what? X1. So let's say that we have here to be, let's call this B, and let's call the whole of this as what? A. Then to find our slope, which is from A to B, or to find the slope or the gradient from point A to B or line AB, how do we go? We said that to find the slope of any 2 point, the slope, we call it what? Always as M. M should be equal to the change in what? the y what value. So we have the change here in b, and then we have the change here in what x, which is in this case what a. So what will be the change that we're getting for b? We're having here as what y2 minus y1 over what is the change that we're having in x is what x2 minus what x1. And this is how we find what the slope or the gradient given any 2 points. So let's take note of that. Let's take an example to find the slope. Now let's say we have these 2 points, point A to be equal to 3, 2, and then we have point B to be equal to negative 4, 1. We are asked to find the slope of these 2 points A and B. How do we find the slope given these 2 points? So all that we need to do is that we need to make a representation when given the 2 points. So we can call this as what? X1. We can call this as what? Y1. Then we can call this as what? X2. Can call this as X2. Then we can call this as what? Y2. So bringing in the formula that we have derived here from the gradient, so the change in y over change in x, we can say that m as the gradient should be equal to y2 minus y1 over x2 minus x1. Then we proceed like that. My y2 from here is what? 1 minus. Then my y1 is what? 2 divided by, then my x2 is what? Negative what? 4. Then x1 is what? Negative 3. So in effect, I'm going to have here as what? Negative 1 over negative 7. Two negatives dividing itself is supposed to result to positive. So 1 over 7 should be the gradient. And we are having a positive gradient. So that means that this gradient is going to have a form like this. It's going to slope like this. When you plot this on a graph, or when we sketch the equation of this gradient on a graph, we're going to have a forward slope. So let's take note of. Let's take another example. We have x to be equal to 4, 2, and y to be equal to 3, and then 3, we have what? 1. So let's see how we can also find the gradient given here. So you just have to quote your formula, but before that, I need to make a representation. So we can call this x1, y1. We can call this x2, y2. So given our formula here, m should be equal to y2 minus y1 over x2 minus x1. So once we're able to have our representation here, we just have to substitute into this formula. So we will have in here, let me bring it here. We will have in here m to be equal to, I know my y2 is what? 1. Then y1 is what? Minus, which is 2, so minus what? 2. Divided by, I know my x2 is 3, minus, then x1 is what? 4. So I'll have m to be equal to, negative 1, then negative what? 1 here. So negative 1, negative 1. I'm supposed to get m to be equal to what? Positive what? 1 or plus 1. It's the same thing. So you're going to have here as what? 1. Because the negative dividing negative will make it positive. So cancel, making it positive, and we'll get m to be 1. So this one too, it will slope like this. So let's take note of that. So this is how we find the gradient when given 2 points. So thank you for watching. So in our next section, we are going to continue with how to find linear equation when given the gradient and any point. So thank you for watching. Bye.